this is lesson 1.5 part 1. This lesson has two separate parts, so this is the first day of 1.5. So we're starting with adjacent angles. Adjacent angles have three things going on. First of all, they share a ray. So it's basically like they share a side of an angle. However, it has to be going the same direction. So I'm going to show you real fast on this next picture what I'm talking about. So both angle EFG and angle HGF share this side, but they do not share a ray. Because if you remember, a ray has an endpoint and then goes forever in one direction. So angle EFG, the ray starts at F and goes forever this way. But on the other angle, it starts, okay, wait, sorry. I gotta change my color. Starts at G and goes forever this way. So even though they share a side, they do not share a ray. So the starting point matters. So for that reason, it's important that they have the same vertex, because if they don't have the same vertex, they can't share a ray. So they have the same vertex, that's the second thing. And the third thing is that they do not overlap. So what that means is like the points on the inside of one angle are not on the inside of another angle. So like these two angles overlap because this angle and this angle, they have points that are on the inside of both of them. Another good example of that is like this right here. I know this says BAC, but if it said BAD, oh, sorry, my tracing's really bad on this thing. Wow, that's really awful. Imagine it, oh gosh, sorry, I can't trace. It's BAD, that's the whole angle, and then the other one is BAC. So they overlap in all of these points right here. So that's what I mean by they cannot overlap. So if it were the entire angle and this angle, those would not be adjacent. Now that's not what that says, so I'll go back over that in a second. And here's what I draw to help you remember adjacent angles. So these two angles right here, this small one and this small one would be adjacent. So I'm going to make my angles into A's and then write adjacent angles. This is just a way to help you remember what they are. Okay, so these first ones, it says BAC, that's the small one, and CAD, that's the other small one. So they do not overlap. They share the ray AC, and they have the same vertex, which is A, so that is yes. Now these, we already talked about. They do not share a ray, and they overlap, so that one's no. So pause the video and see if you can come up with what you think these two are. This one's talking about J and M, and this one's talking about L and K. These have the same vertex, it's N. They don't overlap. This one's all the points down here, and this one's all the points up here. But the answer is no. A lot of people tell me this one's yes, but it's not. It's no, and that's because they don't share a ray. This one's made up of NL and NK, and that one's NM and NJ. So they do not share a ray, so that's no. These angles don't overlap, so that's good, but they don't have the same vertex and they don't share a ray. Now they share a side, but it's the same thing as this one. The ray starts here and goes forever this way, and the other ray starts here and goes forever that way. So that's no. All right, so on this lesson we just have one geometry statement, I'm sorry. And it's really two separate ones, but it's definition of complementary angles and definition of supplementary angles. Both of them are just two angles added together. Complementary means they add to 90, and supplementary means they add to 180. They could be adjacent, but they don't have to be. And if you have trouble remembering that, I think about the letter C and the letter S, because that's complementary and that's supplementary. And you can always turn the C into 90 degrees, and you can turn the S for supplementary into 180. And there's a poster in my room that will say that, in case you ever forget it. All right, so this one says that they are complementary angles. So we're trying to prove that A is 44 degrees. So if A and B are complementary, by the definition of complementary angles, that means if I add them together, they should equal 90. Now, when we started proofs, I told you there are rarely numbers in the first line. And theorems like this are why I said rarely, because there are sometimes where the actual geometry statement has a number in it. So anytime you were doing either one of these, you're setting them equal to 90 or 180. So it will have a number in it. It's just not a number from the problem. So this is definition of complementary angles. So you can write def complementary angles. Then we have 5x plus 4 plus 7x minus 10 equals 90. That's substitution. Then I would combine my like terms and get 12x minus 6 equals 90. You could also write arithmetic there, that's fine. Then I'd add the 6, get 12x equals 96. That's addition. Then you'll divide both sides by 12 and get x equals 8. Now once you get x, you got to figure out what you're really looking for. That's the measure of angle A. So right now, what we know about A is that it equals 5x plus 4. And that's just given to us in the problem. Now we can plug the 8 into here. That's substitution. And then once you solve that, you get 44. And remember, when you just do math on one side, it's arithmetic. Okay, so I'm going to solve this one right here, and then I'm going to want you to pause the video and try this one. So if they are complementary, they add up to 90. So I'm going to, because there's not a lot of room here, I'm going to combine these in my head. So if I add 11x and 4x, I get 15x. And if I add negative 2 and 17, I get positive 15. So all I did was combine these two, which just means I added them together, and they should equal 90. Then I subtract my 15, I get 15x equals 75. Then I divide both sides by 15 and get x equals 5. Now once I get x, it's asking for a and b, so I got to plug it into x. So 4 times 5 minus 2, and 11 times 5 plus 17. Just plugging it into these two equations. So 4 times 5 is 20, 20 minus 2 is 18. 11 times 5 is 55, plus 17, let's see, 55 plus 7 would be 62. Carry the 6. Wait, sorry. I was trying to do two different kinds of math in my head. So 72. Let's move this. I should have just done that instead of trying to do math in my head. Okay, so now I want you to pause the video and try this one. So after I combine my like terms, I get 14x minus 8 equals 90. I went ahead and combined them. 14x equals 98 because you add the 8 to both sides. X equals 7. Then you plug it back in to x in both of these, and you should get 33 and 57. Okay, the only way that this one's different is now it says supplementary instead of complementary, which just means you add them to equal 180 instead of 90. So 7x minus 3 plus x minus 1 equals 180. 7x and x make 8x. Negative 1 and negative 3 make negative 4. Oh, sorry. My brain's ahead a step. So this is 180. Then I add the 4 and I get 8x equals 184. So then I divide and I think you get 23. You'll plug 23 in right there, and then 7 times 23 right there. Subtract the 3, subtract the 1, all that. And you should get 158 and 22. So pause the video and see if you can do these. I think this is, yeah, that's the last slide. So pause and try this, and then I will work them out. So I'm combining like terms before I write down the first step. So I add these two whole things together, and I get 19x plus 9 equals 180. And on this one, I get 25x plus 30 equals 180. If you need to write that out, I did on this one. I wrote out the whole first step. But what I'm doing on the other side is I'm just starting right here. I'm just looking at these, looking at these, plugging in, or adding them, and writing it down. Okay, so I'm going to subtract the 9 and get 19x equals 171, and then x equals 9. On this one, I get 25x equals 150, x equals 6. Then I want to plug in the 9. So you do like 9 times 11 plus 2. That's 101. 9 times 8 plus 7. That's 79. You'll plug the 6 in for x right there and there, and you should get 88 and 92. And that's all for 1.5 part 1.